Hello students, good morning. Welcome in the lecture number 19 of a chapter of chemical thermodynamics, and we are continuing here with the numerical examples. In the last lecture 4 examples we have completed, and this is the numerical example number 13 from your book. For a certain reaction, delta H0 is plus 219 kilojoule, delta S0 minus 21 joule per degree Kelvin. Determine whether the reaction is spontaneous or non-spontaneous. We have seen the chart. We have seen a chart where delta H, delta S, delta G and the type of process we have studied. There we have seen that if delta H is negative, process is spontaneous. Delta S positive, process is spontaneous, and if this is the data, delta G is always negative and the process is spontaneous at all temperature. Secondly, we have studied if delta H is positive, then this is non-spontaneous. Delta S is negative, this is non-spontaneous. So delta G comes to be positive and the process is non-spontaneous at all temperature. This data we have studied, and this is the data given. Delta H is positive, so this process must be non-spontaneous. Delta S is negative, this process must be non-spontaneous, and without any solution also we can tell that this reaction to which delta H is this value, delta S is this value, the process is non-spontaneous. Without any calculation also we can tell it. But let us see, since delta H is positive, delta S is negative, value of delta G must be positive because this reaction is non-spontaneous. So let us see the solution. Here given data for this problem is, they have given delta H under standard conditions, it is 219 kilojoule. Then delta S0 under standard conditions minus 21 joule. 21 joule. This is kilojoule, this is joule. Therefore, convert this joule into kilojoule. Multiply it by 10 raised to minus 3. Whenever this is multiplied by 10 raised to minus 3, now it will be kilojoule. Therefore, delta S0 will be minus 0.021 kilojoule per degree Kelvin. This is the data they have given for a certain reaction. Under standard conditions, means the temperature we have to use under standard conditions will be 298 Kelvin. So this is the data, and using this data we can calculate the value of delta G. Therefore, we know the equation of delta G. It is equal to delta H minus T delta S. Delta H given 219 kilojoule minus temperature 298 multiplied by delta S minus 0.021. So it is 219 in kilojoule. Delta S also in the kilojoule we have taken, minus this multiplication we have to solve. Negative sign. Delta S has given a negative sign. This multiplication we have to solve. We can multiply directly by 21 to 298, or maybe by taking log of first term, log of second term, addition and then antilog. Anyway, it is possible. Minus into minus, this now become plus, and if this calculation is performed, the multiplication comes equal to 6.258. 6.258, this multiplication. Now this is plus, this is also plus, so simply they are added. 219 plus 6 means 225.258 we have calculated, gives free energy kilojoule. So this is also in the kilojoule. Since the answer is positive, this process is non-spontaneous. We know that as delta G is positive, the process is non-spontaneous at all temperature, because delta H is positive, non-spontaneous, delta S negative, non-spontaneous, and we are getting delta G also positive, therefore non-spontaneous. From all these three type of values, the process is non-spontaneous at any given temperature. So this is about the question number 13, and we can predict it without any calculation about the spontaneity or non-spontaneity of the chemical reaction. Now let us see the next problem, that is problem number now see problem number 14. Now see question number 14, problem number 14. Determine whether the following reaction is spontaneous under standard conditions. This is the reaction given, and we have to find out whether this reaction is spontaneous or non-spontaneous under standard conditions, that is 298 Kelvin temperature. Delta H is given and delta S is also given. Just now we have taken the problem of same type. Again see the similar type of chart. We have studied this chart, delta H, then delta S, then delta G, and the type of process. If this is negative, the process is spontaneous. Positive, process is spontaneous. Therefore this comes negative, the process is spontaneous at all temperature. Secondly, if this is positive, the process is non-spontaneous. This is negative, the process is non-spontaneous. Therefore this comes to be positive and the process is non-spontaneous at all temperature. And this data is given for this problem also. See, delta H is given as positive, delta S is given as negative. Here the process is positive means non-spontaneous, here negative means non-spontaneous. In both cases it is non-spontaneous. So without any calculation, here also we can tell that this process is not spontaneous. It is a non-spontaneous process. It is not spontaneous, it is non-spontaneous process. But still, let us find what is the value of delta G. Is it coming to be positive or negative? So here given data of this problem, given data, delta H they have given as 196 kilojoule, delta S naught minus 126 joule per degree Kelvin. This is kilojoule, so convert this also into the kilojoule. This is multiplied by 10 raised to minus 3, so it becomes kilojoule, or delta S naught is equal to minus 0.126 kilojoule per degree Kelvin. And standard conditions means temperature we have to use is 298 Kelvin, and same as that of the previous problem, that is just now we have studied problem number 13. Similar type of calculations here also we have to perform. Delta G will be equal to delta H minus T delta S. Delta G we have to calculate, delta H and delta S known, temperature is also known. Since this is positive, process is non-spontaneous, this is negative, process is non-spontaneous, this answer should be positive. So delta G is equal to delta H, what is value? 196 kilojoule, minus temperature 298 Kelvin, multiplied by delta S 0.126. So delta G naught will be equal to, delta S naught is minus 0.126 kilojoule per degree Kelvin. This is minus, this is also minus, so minus minus it become plus. 196 plus this multiplication, log of 298 plus log of 0.126, and then see the antilog, that answer comes to be equal to, see what is that answer? That answer comes to be equal to 37.55. This is 37.55. Log of this term plus log of this term and then antilog. Final answer is this one. So 196 plus 37.55. Just simply do the addition. Delta G naught will be equal to, this is plus, this is also plus. So answer is also positive. It is 0.55, 6, 7, 13. 1 is carried 4, 9, 4, 13. 1 is carried 1, 1, 2 plus 233.55 kilojoule is the answer of free energy. Since this is positive, we know that the process is non-spontaneous, and as per that chart, this is the non-spontaneous process at any given temperature, because value of delta H they have given positive, delta S they have given negative. Therefore, this reaction is always non-spontaneous at any given temperature. But this is how we have to find out the correct answer. Here you have to calculate this answer only. This answer you have to calculate. Remember, see the log of this term plus log of this term and then antilog. Answer comes to be like this. And minus into minus. Therefore, the answer will be plus. Therefore, 196 plus 37.55. This is the answer, and the process is non-spontaneous. Now let us see problem number 12. Calculate standard enthalpy of the reaction. Calculate standard enthalpy of this reaction. Fe2O3 solid plus 3CO gas giving 2 Fe solid plus 3 CO2 gas from the following data. In the data, they have given enthalpy of formation delta HF. HF over here means enthalpy of formation of Fe2O3 is given. Enthalpy of formation of CO gas is given. Enthalpy of formation of CO2 gas is given. So, see, important one thing here. Enthalpy of formation of Fe2O3 is given, CO is given, CO2 is also given, but Fe is not given. Why the enthalpy of formation of Fe is not given? Because enthalpy of formation of any substance under standard conditions in its absolute state of system, absolute state is considered to be 0. Enthalpy of a substance in its absolute state is considered to be 0. Therefore, enthalpy of formation of Fe we have to consider as 0. We have to consider as 0 during the solution of problems. because this is not given, only that is not the reason. The reason is that enthalpy of a substance under standard conditions in absolute state of system is considered to be 0. This is the reaction. We have to calculate standard enthalpy of the reaction. Means we have to calculate heat of reaction, enthalpy change during the reaction, and we know that enthalpy change of reaction, delta H of reaction is nothing but summation of delta H of products minus summation of delta H of reactants. Now it is very simple. We have to calculate the enthalpy of reaction. Since we know the formula, enthalpy of summation of product minus summation of enthalpy of the reactants. This gives us the answer of enthalpy of this reaction. Now, in this equation, substitute the values and find out the answer. See, what is it? Delta H of this reaction will be equal to enthalpy of products minus enthalpy of reactants. Which are the products? Fe and CO2. These are the two products. So here, how many moles of Fe are there? 2 moles. 2 moles of Fe multiplied by enthalpy of Fe, delta H of formation of Fe, plus how many moles of CO2? 3. So 3 moles of CO2 multiplied by enthalpy of formation of 1 mole of CO2. 1 mole of CO2, they have given answer here, value they have given, but 3 moles are obtained. So this value we have to multiply by 3. So this is about the enthalpy of products minus enthalpy of reactants. There are 2 reactants, Fe2O3. How many moles? Only 1 mole. 1 mole of Fe2O3 into enthalpy of formation of Fe2O3 minus second one, 3 moles of CO. 3 moles of CO multiplied by enthalpy of formation of carbon monoxide. Now substitute the values. Delta H of reaction will be equal to 2 moles of Fe, 2 multiplied by enthalpy of formation of Fe. What is the value? I have told here 0, plus 3 moles of CO2 multiplied by enthalpy of formation of CO2. What is the value? Minus 393. Then minus 1 mole of Fe2O3 means 1 multiplied by enthalpy of formation of Fe2O3. Enthalpy of formation of Fe2O3 is minus 824. Again minus, what is it? 3 moles of CO means 3 multiplied by enthalpy of formation of carbon monoxide minus 110. See this carefully. Important to calculate the answer over here. So delta H of the reaction will be equal to, this is 0. 3 into this factor minus. So answer is minus. 3 3s are 9. 3 9s are 27. 3 3s are 9 plus 2, 11. Minus 1179. 3 3s are 9. 3 9s are 27, 2 is carried. 3 3s are 9 plus 2, 11. So minus 1179. Then this is minus into minus, that become plus 824. Again minus into minus, it become plus 3 into 110, that will be 330. So delta H of reaction will be equal to minus 1179 plus summation of these two terms 4, 3 plus 2, 5, 8 plus 3, 11. So finally answer is delta H of this reaction will be, this is bigger with negative sign and small term with a positive sign. So what is the answer? Is it positive or negative? This is negative. 9 minus 4, it is 5. 7 minus 5, 2. And then 0. So minus 25 kilojoule is the final answer for enthalpy of this reaction. See how we have calculated this answer. First of all, consider the value of enthalpy of formation of iron in standard state condition 0, and then enthalpy of reaction in the thermochemistry we have studied. It is summation of enthalpy of product minus summation of enthalpy of the reactant. This difference is nothing but enthalpy change of the reaction. So enthalpy of reaction, substituting the values, is nothing but 2 moles of Fe multiplied by enthalpy of formation of Fe, then plus 3 moles of CO2 multiplied by enthalpy of formation of CO2 minus reactant, means minus 1 mole of Fe2O3 into enthalpy of formation of Fe2O3, then minus 3 moles of carbon monoxide into enthalpy of formation of carbon monoxide, and then substituting the values 2 into 0, 3 into minus 393, minus 1 into minus 824, minus 3 into minus 110, solving the answers. This is 0, this is minus 1179, this is 824, minus 1 is plus 330. So doing addition, this is 1154, this is minus 1179. Among these two terms, which is the bigger one? Is it negative or positive? Negative. Negative term is bigger one. So negative minus positive, but give the sign of negative, and the answer will be by this subtraction 25. Therefore delta H of reaction is minus 25 kilojoule. Enthalpy change of this reaction therefore is minus 25 kilojoule. Now let us see problem number 18. Problem number 18. Now see problem number 18. When 6 gram of oxygen react with ClF, as per this reaction 2ClF plus O2 giving Cl2O gas plus OF2 gas, the enthalpy change is 38.55 kilojoule. What is the standard enthalpy of reaction? Standard enthalpy of reaction we have to calculate under standard conditions of temperature and pressure. For 6 gram of oxygen, they have given this value 38.55 kilojoule. Enthalpy of reaction we have to calculate. We know enthalpy of reaction is the summation of enthalpy of products minus summation of enthalpy of the reactants. But enthalpy of product and reactant is not given. Instead of that, directly they have given the enthalpy change, that is enthalpy of this reaction whenever 6 gram of oxygen is involved in the reaction. How much gram of oxygen is actually involved in this reaction? 1 mole. means how many grams? 32 grams. 32 grams oxygen when inhaled. We have to calculate the enthalpy change. For 6 gram of oxygen, they have given this enthalpy change. So very simple to calculate the enthalpy change. Whenever 6 gram of oxygen is inhaled, enthalpy change of reaction delta H is 38.55 kilojoule. For 6 gram, enthalpy change is 38.55 kilojoule. And they have asked to calculate the enthalpy change of this reaction under standard conditions. In this reaction, how many grams of oxygen is inhaled? What is the molar mass of oxygen? 32. So 6 gram is this value. 32 gram of oxygen will have how much value? X value of delta H. This X we have to calculate just in a single step, and that is the answer. So X doing cross multiplication will be equal to 38.55 multiplied by 32 divided by 6. We can do this simple calculation even without using log also. So 38.55 multiplied by 32. 2 5s are 10. 2 5s are 10 plus 1, 11. 2 8s are 16 plus 1, 17. 2 3s are 6 plus 1, 7. Now 3 5s are 15. 1 is carried. 3 5s are 15 plus 1, 16. 3 8s are 24 plus 1, 25. 2 is carried. 3 3s are 9 plus 2, 11. Do the summation. 0, 6, 13. 1 is carried, so again 13, and now this is 12. 1 2 1 2. So this is X is equal to 1233.660 divided by 6. So X is equal to 6 2s are 12, 3, so it is 0. 6 5s are 30, 3 is remaining there, then 6. So 36. 36 divided by 6, it will be 5. 6 5s are 30, 6 5s are 30, 6 are 36. So directly we can write it as a 6 also. Answer is positive. Plus 205.6 is the amount of enthalpy change obtained during this reaction under standard conditions of temperature and pressure. This is the final answer. Very simple. See, such problems are one-step problems. In a single step, we can calculate the answer. We have given 6 gram of oxygen and this is enthalpy change. And in the reaction, 32 gram of oxygen is used and we have to calculate the answer. So very simple. 6 gram has this value, 32 gram will have how much value? This answer we can calculate directly without using log table also. This is how single step problems can also be solved on the basis of enthalpy and enthalpy change. These are important problems even from the point of our competitive exam like MHT, CET also. Here we must know certain basic terms. We must know enthalpy of formation. Then we must know enthalpy of combustion and the enthalpy of reaction. What is enthalpy of reaction? Enthalpy of reaction is the enthalpy change during a chemical reaction when your reactants are converted to product. And how that is calculated? Enthalpy of reaction is the difference between summation of enthalpy of product and summation of enthalpy of the reactant. What is enthalpy of combustion? That is the enthalpy change whenever 1 mole of substance undergo combustion in presence of excess of oxygen to form stable oxidation product CO2 and H2. Only 1 mole of a substance we have to use. Similarly, what is enthalpy of formation? That is the enthalpy change. Whenever only one mole of substance is formed from its constituent elements under standard conditions of temperature and pressure. We must know these basic definitions in order to calculate the enthalpy change during any type of the chemical reaction. So with that, we have completed the chapter of thermodynamics from all corners. We have taken numerical examples also. Some of the numerical examples are still there. Just 2 to 3 numerical examples are there. Those numerical examples you have to solve as your homework, as your practice, so that you are able to solve the numericals from the chapter of chemical thermodynamics. Here we have completed a chapter of chemical thermodynamics from all corners along with the numerical examples also.